Okay, in our last video we graphed this function. Now let's start addressing some of these concerns like the domain and range here. So here's the graph of the function. I'm going to eliminate some of this other stuff that we no longer need. Again, you want to keep your work, but we won't be needing this for now. So let's just make some changes. All right, we got this here. Maybe we can just start moving this around. So here's our graph of our function. So the domain are the x values that work for the graph, and if I start thinking about what x values I can plug into here, I can't think of an x value I can't plug in, which means the domain should be all real numbers. And visually what that means is this graph goes forever to the left and forever to the right. Remember, the domain is how wide the graph is, or the x values that are mapped to a y value. So this x value is mapped to a y value here. This x value is mapped to a y value about right here, and if I had an x value here, it would go all the way up and way off the screen, but it would eventually get mapped to a y value. So the domain is all reals, all real numbers, all reals. The range is where we run into something a little different. I'll erase this viewing window here so we just have a complete view of this graph. You'll notice that the graph has a horizontal asymptote at y equals 3, and when we studied rationals, we know that it is possible to cross a horizontal asymptote, but for an exponential does not cross its horizontal asymptote. So this graph will never get below -3. So when I'm looking for the y values, the lowest y value this graph will get to is the number just above 3. So my lowest y value would be 3, but not including 3. So 3 is less than y. Now my highest y value, this graph shoots up forever. My highest y value, the graph will just keep going to infinity. It doesn't actually get to infinity, but it'll approach infinity. So the range of this is between 3 and infinity, and you can see this in our graphing calculator. We'll pull up the graph here. There's the negative. If I go to forever to the left here, you'll notice this graph is never going to go down. We'll look at the table as I take x to -4, -7. You see it gets closer and closer to -3, and then the graphing calculator, once it gets to -12, just says, hey, the graph is -3, even though in reality it's not. It's just really, really close. And as I go to the right, you'll see the graph goes up forever and ever and ever till the graphing calculator finally just says, hey, look, this is 2.1 times 10 to the 6, which means you move this decimal place 6 places to the right, and it's just giving you a ballpark of what the number is. The number becomes so large. Okay, we've got our domain and range. We've already talked about the horizontal asymptote quite a bit right here. That's just y equals 0, and the trick here is making sure you remember to write that it's y equals 0 and not simply 0. This is an equation, or excuse me, it's not y equals 0. That's the parent function. The horizontal asymptote is y equals -3, which is right here. Vertical asymptote, this graph, no, exponential functions don't have vertical asymptotes, so it's just not applicable to this function, and we know that because it goes forever to the left, forever to the right, and there's not an x value I can plug into here that causes us a problem. Okay, talking about whether graph is decreasing, if you imagine that you're over here on the far left of this graph and you're walking to the right, so I'm a guy right here and I'm just walking this way, the whole time I'm walking, I'll be walking upward. So this graph doesn't ever decrease. There is no interval where the graph is decreasing. So again here, this is not applicable. The zeros. Okay, the zeros is when the graph crosses the x-axis. I can clearly see that there are zeros. There's a zero right here. I could find this zero by plugging in 0 for f of x and solving this equation. So for the zeros, I mean when f of x equals 0, so 0 equals 2 raised to the x plus 1 minus 3. I could solve this equation and find this. But we have this graph in the calculator. So we're going to go use the graphing calculator to find this value right here. So that's the zeros are second calc, and we actually have something that's called zero. And the calculator tells you to get the left bound. Well, put your spider where you think the zero is. That's right there. And take it to the left. All right, so there's to the left. And then it says right bound. So I'll put the spider right on the zero, and then I'll take it a little bit to the right. Press enter. And you'll notice that you've created an interval, and in that interval, your zero is contained. So it tells you to guess. Put the spider just right in the middle there. And it'll say 0 is 0.5849625 and y is 0. So I can round this to 0.585. 0.585. And then there's the y-intercept, and we've actually already found the y-intercept for this graph. It's right here at y is -1, but let's just go ahead and confirm that by going to starting the table at 0. And so this starts the x value of the table at 0. And remember, when x is 0, you're given the y-intercept. So -1 is my y-intercept here. Intervals where the graph is increasing. Well, we discussed this as this guy's walking from left to right. He's constantly going up. So the whole over the whole domain of this function, the graph is increasing. So that's from -infinity is less than x is less than +infinity. Okay, and that's the questions I'm going to answer in this video. In the next video, I'll show you how to find f of 56 and the value of x when f of x equals 12.